In this video, we want to switch gears a little bit and move from simple interest to something called compound interest. So if you recall, simple interest involves interest that's calculated once only on the original principal amount. With compound interest, the interest is actually computed on the original principal as well as any accumulated interest, and it's calculated at certain intervals of time. It might be compounded annually, so they would do that every once a year. So whatever interest you earn at the end of the year, that now becomes part of your principal. So the next year, your interest is earned on the original amount plus that little bit of interest you earned. It can be compounded in different periods of time we'll talk about in a few minutes. This is how credit cards are done. This is how most mortgages and car payments are done as well now. All right, so there's a big difference. And at first it doesn't seem like it, depending on how frequently the compounding is or in how long a period it is. But if it's for a substantial length of time with pretty frequent compounding, it can be a huge difference between simple and compound interest. All right, so let's take a look at the formula. Now, don't get intimidated with all the little letters and arrows and things. Here's the formula from your book. P sub n, which always stands for the amount in the future at time n, equals P sub 0. So again, we're starting with the principal, the original amount, times 0, times the quantity. Here's where it gets a little different. We're going to do 1 plus r over this k, and then all of that's going to be raised to an exponent of nk. Okay, so P sub n, still future amount. P sub 0, still the original amount. And r is still the rate, which is good. N is still the time in years. The k is the new thing. So k is going to represent the number of compounding periods per year. Now, up in the corner on our notes here, I've put another formula. So if you go out there and you're looking on the internet, you're looking at another textbook, like for instance, our college algebra book, it's going to give you a formula that looks similar, but the letters are a little different. But it really, if you know what those letters stand for, it is exactly the same formula. So I just didn't want you to be confused if you see two different things out there. I'm going to use the one that goes along with our textbook through all our notes. All right, so suppose that we have $750 invested at 7%, compounded semi-annually. We want to find the amount of money after 5 years. All right, so the 750, that's what's originally, that's my P sub 0. The 7% obviously is my rate. It's compounded semi-annually. Well, if you're a shopper, you know that semi-annual sales means we do it twice a year. So semi-annually means my compounding periods are going to be twice in a year. And then it tells me here the number of years. So plugging all of that into my calculator, I get a total of 1,057.95. Now hit pause a second and put this in your calculator and see if you get the same thing. All right, if you didn't, I'm going to tell you where I think you probably had the issue, all right? I'm just going to get my little pen out here and say it probably has to do with, oops, that's not what I wanted to do. The exponent, all right? When you put this in your calculator, if you just put parentheses and then raise it up, let me show you what I mean. If I just do this, 750, and then the parenthesis, 1 plus 0.07 divided by 2 and close parenthesis. And then I use that caret to make an exponent. And I just put in 5 times 2. My calculator is going to follow order of operations, which does inside the parenthesis, then it does the exponents, then it does the multiplication. So what it's doing is raising that value to the 5th power and multiplying the result by 2. That's not what we want. So instead, if you either put parentheses around that 5 times 2, or since this one's pretty easy, I'm just going to change that to 10. Oops, let's try that again. 10, and hit enter. Now I get the correct answer. Okay, so the formulas are given to you. Most of the time it's going to be pretty straightforward to know which one to use, but you have to know how to communicate with your calculator and that technology so that we can get an accurate answer out of that. All right, well, there's one more piece to this problem. It says, well, how much interest is there? Well, remember, interest is the future amount minus what you invested. So our future amount we just calculated, the original was the $750, so we had $307 in interest. Okay, now I want to make sure that you feel comfortable with this. So I've highlighted a few problems here, the yellow highlights number 2, 6, 8, and 10. I've given you the compound interest formula. So I would encourage you to hit that pause button and see if you can calculate all of these. And then I'm going to run through the answers quickly. Okay, so what are we going to do? The first one, it says that we are compounding annually. So when it says annually, that's one time a year. So my K, you notice, is just a 1. When I put it in my calculator, I can kind of ignore it, right? Dividing by 1, multiplying by 1, I just get whatever number was there. So your answer for that one should have been $9,528.13. What about number 6? Well, it says it's compounding quarterly. Well, a quarter, there are 4 quarters in a year, so my K this time I changed to the 4. So just like we talked about in the last video, if you don't multiply that exponent 6 times 4 in your head and get 24, you will want to put parentheses around it when you put it in your calculator. So let's see, how'd you do? The correct answer for this one, $4,021.09. All right, number 8, that same $2,500, but this time 6.5% compounded monthly. Well, monthly means 12 months in a year, so 12 times a year. So my K this time is 12. Everything else is, set up the same way. So very carefully putting that in your calculator, you should come up with $3,240, let's say it that way, $3,240.05. And then that last one. Okay, now I put in here a note that says use the banker's rule for daily interest. Now you might not have seen that a minute ago, but you can recalculate it real quickly if you didn't. In a previous video, we mentioned banker's rule means that you're going to use 360 days for a year, even though in a normal year there's 365. Okay, it's just a nicer number. So we're going to use the banker's rule, which means my K is going to be 360 for number 10. And when I put that all in my calculator, I'm coming up with, and I don't know if you can see that. Let's see if I can make that go up a little bit higher. Not having much luck here. Well, I'm going to just read it to you. $1,615.73. Again, if you're having any trouble with that calculator, getting things in there, getting the right answers out, please let me know. I don't need to be frustrated. It's usually a very simple, quick answer.